Let's extend simple to a bigger language. We're going to push out towards core OCaml now by adding anonymous functions and function application. How could we give a big step environment model semantics for this? Well, since functions are values, we could say that evaluating the anonymous function, fun x arrow e, inside of an environment env just gives you back the value. Much like if we were just evaluating an integer value, it would just give us back that integer. This is tempting, simple, and very, very wrong. I'm going to show you why in a minute. What about function application? Well, we could say that to evaluate E1 applied to E2, we first evaluate E1. Of course, if this expression type checked, that has to give us back a function eventually. So let's say that that's the function fun x arrow e. We could evaluate the argument E2 to a value V2. And then, quite like we did for let expressions before, we could extend the dynamic environment to bind x to V2 and evaluate the function body E. That would give us back eventually a value V. That would be the result of the entire function application. Once more, this is tempting, simple, and wrong. So what's the problem? Well, here's a little piece of code that will help make it clearer. Suppose we bind x to 1, and then we bind f to the function fun y arrow x. Then we rebind x to 2 and call f on 0. So what should this evaluate to? It all comes down to which binding of x should get used. Is it the binding of x to 1 or the binding of x to 2? Please take a minute, stop the video, and you decide what you think the result should be. Okay, perhaps some of you put that into UTOP. If so, I applaud you. What does OCaml say that this evaluates to? Well, when I put it in UTOP, I got back that it evaluated to 1. So it was the binding of x to 1 that in the end was used. But what does our semantics currently say? Well, I've taken the program here, and I've annotated each line with what the dynamic environment would be at the beginning of that line. So on line 2, we have a dynamic environment that binds x to 1. On line 3, that has been extended to bind f to the function fun y arrow x. On line 4, we've then rebound x to B2. And now in that dynamic environment, we need to evaluate f applied to 0. So what is that, according to the semantics that we just gave? Well, first we would evaluate f to a value. That would be the function fun y arrow x. All we have to do is look that up in the dynamic environment. Second, we would evaluate its argument 0 to a value. It's already a value. Third, we would extend the environment to map that function parameter. So y, the parameter of that function, would be bound to 0, which is the argument being passed in. Then we would evaluate the body of the function in the current environment. And in that environment, when we look up x, we get 2. So we would return 2 as the result of evaluation. Well, I hope you'll agree with me. 2 is not equal to 1. So OCaml's semantics versus the semantics we've written down at this point do not agree on how this program evaluates. That's why I said that the semantics was wrong. So why are we getting two different answers? It's because there are two ways of defining variable scope that we're exploring right now. One is called the rule of dynamic scope, and that's what our, quote, wrong semantics has been using so far. Now, I'm going to backpedal a little bit here. It's not that it's wrong, it's that it's not what you expect according to OCaml's semantics. We'll come back to that later and discuss it more. The OCaml semantics, or the quote, right semantics, uses what's called the rule of lexical scope. The rule of dynamic scope says that the body of a function is evaluated in the current environment at the time the function is called, not in the old environment that existed at the time the function was defined. So that difference between which environment gets used for the body is what caused our semantics to use the latest binding of x, the one at the time the function was called. And that caused it to return 2. The rule of lexical scope says that the body of a function is evaluated in the old environment at the time the function was defined, not in the current environment at the time the function is called. And that's what caused OCaml to use the earlier binding of x from when the function had been defined, and thus return 1. So OCaml's semantics to get lexical scope requires returning to an old environment at the time a function is called, because you can't keep using the new environment. You've got to go back in time to that old environment at the time the function was defined. What that means is that OCaml semantics requires implementing time travel.